Hi guys, so welcome back sa ating YouTube channel. So ito na yung lesson 30 para sa ating Advanced Calculus 1. So it's been a year since nung huli ako nag-upload dito sa playlist na to. But again, kailangan ko kasi mag-upload. Kailangan ko siyang dagdagan for the purpose na magkaroon siya ng mga activity. And at the same time, part talaga siya ng ating discussion o ng ating course syllabus. Okay, so in this lesson, pag-uusapan natin yung indeterminate forms and the Lopital's Rule. So yung iba, binabasa siya as LHopitals Rule, pero ang basa ko siya niya is Lopital's Rule. Okay, so question to founder lang or start lang natin para magkaroon tayo ng idea bakit nga ba nagkakaroon ng ganito, no? So kung aware ka, ang ginagawa natin technically or algebraically sa limit is, ang ginagawa natin is sinasubstitute lang yung value. So for example, yung limit as x approaches to a fixed number or something, whether it's infinity, a number from the left or a number from the right, negative infinity, or any constant or any fixed value, anong nangyari is literal sinasubstitute natin, but not most of the time. So hindi sa lahat na oras sadya right away sinasubstitute natin siya. So may mga instances kasi ang ginagawa lang natin is just ang ginagawa natin is ina-apply natin yung mga different method o yung mga different procedure na natutunan natin. Andiyan yung change of variable, so kung saan papalitan natin yung order of limits o yung limits nila. Then magkakaroon din tayo ng mga techniques o yung mga formula. Minsan gumagamit tayo ng trigonometric identities, minsan may factoring or algebraically ginagawa natin siya, then nagsisimplify tayo. So minsan nagde-divide tayo or nagka-factor out tayo para lang ma-deduce, then saka natin ina-apply yung mga limits. So napakadaming approach pagdating dito. So hindi ko rin sure kung formally ko na nabigay or nabigyan ng definition si Lopital's Rule kung paano siya ginagawa, pero I think napaka-familiar na nating lahat doon. Okay, so in this video or in this dalawang video na pag-uusapan natin is indeterminate forms and the Lopital's Rule. So ito yung pinaka mahalaga. Kumbaga, hindi naman totally pinakamahalaga, pinakamahalagang mga G's or mga facts about dito. So kailan nga ba nagkakaroon ng indeterminate form? Ano ba yung dapat nating gawin para ma-solve yung mga limit na indeterminate form? Okay, so we start with the very basic. So letter A, we have the indeterminate forms of the type 0 over 0 and infinity over infinity. So yung infinity over infinity na dyan, pasok dyan yung infinity over negative infinity over infinity, negative infinity over negative infinity. So wag nyong isipin na nasa positive or nasa positive infinity lang siya, pagkos pasok din dyan yung negative infinity over negative infinity, then yung iba pang sinabi ko. Okay, alright. So now, let's start with the definition. So ano nga ba yung mga limit o yung mga klaseng limit yung nag-e-exist o yung napupunta sa form, sa indeterminate form of type na ganyan? Okay, let's have a definition. So the limit of f of x over g of x as x approaches a is an indeterminate form of type, number 1, it is 0 over 0 whenever or if the limit of f of x as x approaches a is equal to the limit of g of x as x approaches a is equal to 0. So, obvious naman yan. So, kung sinubstitute mo right away, rekta. So, ang ibig sabihin lang yan, kunyari sinubstitute mo rekta yung ating value ng x doon sa loob ng ating limit. Tapos, ang naging result ng numerator then denominator is 0. Then, automatically, this is an indeterminate form of type 0 over 0. So, again, that is 0 over 0. So, sir, paano po pag 0 times 0? 0 times 0 is obviously 0. So, walang problema about doon. So, again, ang goal lang nito is dapat maging 0 over 0. So, not necessarily goal. So, parang ito lang yung type niya. So, kung maging 0 over 0 siya, automatic indeterminate form of type 0 over 0 siya. Okay, then number 2, infinity over infinity or yung iba pang infinity if the limit of f of x as x approaches a and limit of g of x as x approaches a are both positive infinity or negative infinity. Okay, so from the word both, no, so kung papansin nyo, from the word both, ibig sabihin pwedeng positive infinity, dalawang positive infinity or dalawang negative infinity. Or ayun nga, andito yung tanong na pwede ba sa negative infinity over infinity or positive infinity over negative infinity? So later on mapag-aaralan or matitignan natin yan kung andyan ba talaga yan. So ayan din yung naglalaro pa sa isip ko. So as we go on, as we move along, pag-aaralan natin yan. So same lang naman tayo dito. Ako sinusolve ko lang siya, binabasa ko lang siya, iniintindi ko lang siya, then nagkakaroon ako ng idea, then dinidiscuss ko siya. So talagang ang nangyari nito, konting basa din, discuss lang din talaga ako. Okay, so start tayo, ano? So let's have an example. So evaluate the following limits. So ito napakadali ng mga una. So wala pa akong tinuturo na kahit anong rule na gagawin natin. Ang gagawin lang natin is just gagawin natin yung procedure na alam natin kung paano siya ginagawa. But before that, bakit nga ba tayo nagpunta sa ganung procedure? So meaning, nangyari, nagkaroon muna ng indeterminate form bago tayo nagpunta sa ganung procedure. So let us consider number 1. So the limit of x squared minus 3x all over 2x squared plus x as x approaches 0 is, so technically or something na kung papansinin mo, no, kung right away isa-substitute ko yung 0 dun sa numerator and denominator, pansinin nyo, that is 0 squared minus 3 times 0, so 0 minus 0, this is 0. Okay, then 2 times 0 square is 0, plus 0 is obviously 0. So meaning this is an indeterminate form of type 0 over 0. So basically, gusto ko ganito gawin nyo, no? So, whenever meron tayong ganyan, ipakita nyo anong klaseng type siya or anong form, anong indeterminate form of type siya. So, tulad nyan, pinakita ko siya na sa 0 over 0. Okay, so lagyan nyo lang ng parenthesis para hindi natin ma-misunderstand or misunderstood na kailangan siyang i-multiply or what. Okay, though, so that is an indeterminate form of type 0 over 0. So, basically, dahil 0 over 0 siya, wala pa ako ibang tinuturo. Ang alam lang natin is yung ating mga way. So, sir, pwede po namin gawin yan through factoring. So, kumbaga ang ginagawa natin, sir, is pa-factor lang po natin yan para po natin magawa yan. So, paano nga ba yun? So, ito po, napaka-basic na lang sa atin ito. So, ang gagawin natin, this is just factoring. So, this is just the limit as x approaches 0. So, factor ko yung x sa taas. So, this is x times x minus 3x. Minus 3 all over x times 2 plus x. Okay, and obviously, that is simply cancel yung x natin dun. So, since makakancel yung x natin dyan, so, basically, this is just simply x minus 3 over 2 plus x. So, therefore, this is just equal sa, so, pagka-cancel, pwede mo naman siguro recta substitute na kasi ganun din naman yung pupuntahan. So, substitute ko na yung 0. So, this is just 0 minus 3 all over 2 plus 0, or simply this is just equals a negative 3 over 2. Okay, so ganun siya kadali. So punta tayo sa number 2. So kailangan dito ng calcul, no? So ano lang ako dito, set up ko lang yung calculator ko sa degree. Okay, so we have the limit of sine 5x over sine 3x as x approaches to 0. So obviously, what is sine 5x? So what is sine 5 times 0? So what is sine 0? Kasi ganun din yung pupuntahan What is sine 0? Sine 0 is 0. So mapapansinin mo, kahit anong gawin ko dyan, i-recta substitute ko yung 0 na yan, then dito sa dalawa, that is sine 0 over sine 0. So hindi mo pwede sabihin, sir, di dun, simplify ko na agad, sine 0 over sine 0. So andun yung parang guguluhin ka, no? Yung tipong, sir, pagka-substitute ko po nung sine nung x sa 0, 5 times 0 is 0, 3 times 0 is 0. So, meron akong sine 0 over sine 0. So, technically po, sir, hindi ko po alam, hindi siya parang nag-i-exist as 0 over 0. No, tama hindi siya nag-i-exist literal na 0 over 0. Bagkus sine 0 over sine 0. So, sir, hindi po pwedeng cancelin siya, or meaning, divide natin both side by sine 0 tapos 1. Pero, ito yung tanong. Pwede ka mag-divide ng any number or any variable or any kahit ano as long as siya ay hindi 0. But sine 0 is equal to 0. Kaya hindi natin pwedeng gawin sine 0 over sine 0 cancel, that is 1. Okay? So ibig sabihin this is just 0 over 0. Yan lang naman yung ibig sabihin sa doon. So baka kasi magtaka ka, no? So sine 0 over sine 0, so canceling ko lang 1 na yun automatic. So again, hindi siya pwede. Now, punta tayo dito. So kung naaalala mo, paano natin sinosolve yung ganito? So pasok tayo dun sa part na kailangan we have the limit of sine x over x as x approaches 0. So ang gagawin natin is just magmumultiply tayo ng number. So kailangan natin ng 5 sa ilalim ng sine 5x. Kailangan natin ng 3 dun sa taas. Okay, so ayun yung aking pagkakaalala, no? Not just 5, kailangan din yung x. So, kailangan ng sin 5x over 5x, then sin 3x over 3x para siya maging 0. So, basically, kailangan natin dito ng multiplier na. Ano yung multiplier natin? This is just equal sa, kailangan natin ng 3 sa taas. So, this is just 3 over 3 multiplied by 5 over 5 multiplied by x over x. So, lahat yan 1. Then, limit as x approaches 0 ng sin 5x over sin 3x. So, next is, syempre, yung 5x lalagay sa ilalim, then yung 3x lalagay sa taas. Then, paghihiwalayin natin. So, ang matitira dito is just, syempre, yung 5 yung matitira sa taas. So, this is just 5 over 3. Then, multiply natin sa limit as x approaches 0 ng sin 5x over 5x. Tapos, pagdadalawin ko na yung limit kasi hiwalayin ko lang yung isang limit na yan, yung sin 3x na yan. So, this is just limit as x approaches 0 ng 3x over 5x. Sorry, 3x lang din pala to. Okay, then, obviously, this is 1 over 1. And this is 1. So, again, kasi ito, reciprocate pa natin. Kaya magiging 1 over 1 pa siya. So, this is just 5 over 3. 5 over 3 multiplied by 1. Multiplied by 1 over 1. Which is equal sa 5 over 3. Okay, so ganun siya kasimple. So, next, number 3. We have the limit of 3x minus 1 all over 7 minus 6x as x approaches positive infinity. Okay, so ganun lang ulit, rekta, substitute mo lang, no? Substitute mo sa numerator, then denominator, check mo kung anong klaseng indeterminate form of type siya. So obviously, this is just 3 times infinity, that is infinity, minus 1, that is also infinity. So regardless, kahit anong i-minus mo sa positive infinity, that is infinity. Next is 7 minus 6 times infinity. So 6 times infinity is infinity. So 7 minus infinity is automatically negative infinity. So therefore, this is just in the form of positive infinity over negative infinity. So meaning, pasok pala yung sinasabi ni Sir kanina. Hindi lang sila basta both. Okay, so I think yung word dito is or. Mas maganda. Pero ayun yung nakalagay sa definition, sinusunod lang naman natin. Okay, so ayun yung kanyang indeterminate form of type. So nagkamali na ako ng ginamit na ballpen. Okay, so now, ano yung gagawin natin sa mga ganitong scenario? Sir, ang ginagawa po natin dyan, kung ako naalala ko is, since parehas naman sila ng degree, kumbaga yung degree sa numerator and degree sa denominator is both x, then approaches infinity siya. Ang typically na ginagawa natin is dinidivide natin each term sa numerator and each term sa denominator by 1 over x or dun sa highest degree or power. So meaning, kung x yung highest degree or x raised to 1 yung highest degree natin or 1, therefore, divide natin lahat yan sa 1 over x. So, this is just equal sa limit as x approaches positive infinity, nilagay ko dito, divide natin or multiply natin lahat sa 1 over x, tas sa 1 over x lahat yan. So this is just 3 minus 1 over x, then this is just 7 over x minus 6. Okay, so as x approaches infinity, yung limit ng 1 over x is 0. As x approaches infinity, yung limit ng 7 over x is 0. Kasi 7 times 0 is just 0. So basically, kung substitute natin, this is just 3 minus 0 all over 7 times 0 minus 6. So, magtataka, sir, saan galing yung 0? 7. Yung 7 galing dun sa 7 over x. Yung 7, pinapactor out. Kasi ang literal lang, guys, is yung 1 over x lang naman talaga. Yung limit ng 1 over x as x approaches infinity lang yung 0. So, ang nangyayari, para siyang constant or para siyang scalar factor sa 7. So, nilabas ko lang sa 7, tapos kinuha ko lang yung limit ng 1 over x na yan, which is 0. So, ganun din naman yung kakalabasan. So, that is 3 over negative 6, or which is, this is just equal sa negative 1/2. So, pasensya na kung pa iba-iba na naman ng ballpen sa set. Kung ano lang yung madampot. So, that's how we do it. Okay? So, yan yung alam natin. kung paano natin ginagawa talaga. So, yan yung mga procedure na naturo ko na dun sa ating mga past video. So, sabihin mo, sir, napakadali, recall pa tayo. So, yun nga, syempre, kailangan ko ipakita bakit nga ba siya nag-i-exist. So, bakit nga ba natin ginagawa yung mga yun? Dahil nga may mga indeterminate form tayo na ginagawa. Okay, so now, let's have theorem. So, we have theorem, this is the L'Hopitals Rule or the LHopitals Rule. So, hindi ko na sabihin kung kanino galing yan, hindi ko rin naman sinearch kung sino siya. So, based on the definition, so let f and g be function differentiable on an open interval I containing a. So, containing a, except possibly at a. So, naturally, yan naman definition pag sa limit eh. So, naturally at a. So, hindi ko sure kung merong bang ganito noon. At a. So, okay. So, at a. So, wala tong ano na to, no? Tatanggal ko lang yung definition. So, wala to. So, wala tong 0. So, for all x element of I of a, I not including a, sorry. I not including a, pakipalitan to. So, a element ng I not including a, not including the set a. Yung interval na hindi kasama yung a. So, if the limit of f of x over g of x as x approaches a is indeterminate of the type 0 over 0 or infinity over infinity, then ito yung gagawin. Ang gagawin lang natin is just the limit of f of x over g of x as x approaches a is equal to the limit of f prime of x over g prime of x as x approaches a. So, anong ginawa? Dinerivative or kinuha yung first derivative o yung dinifferentiate yung first natin. Okay, dinifferentiate siya. So, meaning, hindi tayo gagamit dito ng quotient rule. Because ang gagamitin, di-differentiate mo lang talaga literal yung numerator individually or independently, then yung denominator, which is g of x, independently. Okay, then, andito rin yung part na nag-i-exist siya continuously. So, ano ibig sabihin sa continuously? Hindi ko sinasabi na first derivative lang ang gagamitin mo. Na hanggang isang beses mo lang pwedeng gamitin si L'Hopitals Rule. Kasi, ganito nangyayari. Once ang isang function, dinifferentiate mo, function pa rin yun. So, kung anong nangyari, yung function na yun over the certain function, nag 0 over 0 pa rin or indeterminate form, function pa rin sila literal. Function sa taas, function sa ilalim, pero 0 over 0 lang pag sinubstitute yung value ng limits. So, ang mangyari, apply pa rin natin si L'Hopital. So, meaning, i-differentiate mo siya ng i-differentiate, provided na dapat nag-i-exist na siya. Ayun yung ibig sabihin. So, ito yung ibig sabihin niya. Provided that the limit of f prime of x over g prime of x as x approaches a exists. So, kung nag-exist na siya, or positive infinity or negative infinity yung result, tigil na. So, paano sir pag hindi? Tuloy-tuloy yung ating L'Hopitals Rule. So, syempre, kaya ako pinapakita yung ganito, kaya ako nilalagay yung ganyan para ipakita mo na, okay, kailangan ko pa mag-L'Hopitals kasi nga, indeterminate pa siya. Okay, pero hindi rin agad necessary na sa lahat ng oras ilo-L'Hopitals mo. So, may mga instances na mangyayari, pagka L'Hopitals mo, tapos pwede mo naman, indeterminate siya, pwede mo naman i-simplify, or kung baga gamitan mo na ibang method, okay lang. Okay, wala naman ng problema doon. Okay, so yun naman yung nature ng ating L'Hopitals Rule. So, next is, baka isipin mo na, sir, pasok lang ba siya sa specific number? Hindi po ba pasok dito yung infinity? Hindi po ba pasok dito yung from the left and from the right? Yung x over a na yan, marami siyang definition dito. So, x approaches a. So, pwede din sa atin sabihin na as x approaches a from the right, as x approaches a from the left, okay, pwede rin x approaches infinity or positive infinity, then x approaches negative infinity. Okay, so baka i-close my mindset muna, nandiyan lang tayo. Okay, so let's proceed, no? Okay, so let's try, no? Meron tayong mga example dito. So, in which pwede natin apply yung ating L'Hopitals Rule. So, ito na ha. So, gagamitin natin L'Hopitals Rule. Hindi ko ako gagamit ng ibang technique. Kung may nakita kang ibang technique other than L'Hopitals Rule, settle aside muna natin yan. L'Hopitals Rule kasi ang topic natin. So, let us evaluate the following limits. So, number 1, we have the limit of, so, hindi nyo makita yata. No? So, ting zoom ko lang guys. Okay, so, yan pa rin eh. So, we have the limit of x squared minus 3x all over 2x squared plus x as x approaches 0. So, sir, may ulit. Yun nga yung purpose ko eh. So, aware na tayo na that is already 0 over 0. We all know that this is already 0 over 0. So meaning, by L'Hopital's rule, apply lang natin. So since 0 over 0 siya by L'Hopital's rule, so hindi mo rin naman kailangan ilagay ito guys. L'Hopital's rule. Ilagay ko lang para makita ng iba. So by L'Hopital's rule, we have, anong gagawin? This is just equal sa limit as x approaches 0 ng derivative with respect sa x. So yan yung tabasa dyan. X squared minus 3x all over derivative with respect sa x ng 2x squared plus x. So I think kilala nyo naman to. So nasabi ko naman yata sa calculus 3 yan. So iba't ibang klaseng form ng derivative. Ang ibig sabihin lang niya ng capital din yan, the derivative with respect sa x. So kung ginawa kong derivative with respect sa y, dy yan. Okay, so that is the derivative with respect sa x. So this is just equal lang sa limit. So wag kalimutan ilagay yung limit kasi nag-differentiate lang tayo guys. Hindi ka pa mag-substitute. So that is 2x. This is 2x minus 3. All over sa ilalim, that is 4x plus 1. Kasi derivative ng 2x squared is 4x. Derivative ng x is 1. So as we substitute x approaches 0, wala naman na maapektuhan, no? 0, 0 lang naman siya. So this is just equal lang naman sa ating negative 3 over 1. So negative 3 over 1 ba yung sagot sa kanina? So nalito ata si sir kanina, no? Or magkaiba ng given. So check ko lang din, ha? So pinactor out ko yung x. So, may 2 plus x. Okay, so dito, pinactor out ko yung x. So, may natirang x minus 3. Then, may natirang 2 plus x. So, yun nga, tama lang. Pero, yun yung nakakapagtaka. Isang mahiwagang pangyayari, guys. Okay. Gets ko na, guys. So, ayun, no. So, I think siguro, anuhin mo rin ako. Baka probably babalikan mo ako dito, no. So dito ko na ayusin habang as we go along na rin. So this is just, kung pinactor natin yung 2x squared plus x, nalito si sir, factor out natin yung x, mga that's x times 2x plus 1. Okay, so 2x plus 1 pala siya guys, no. So this is just 2 times 0 plus 1. So this is just only negative 3. So ayun, ayos ko na, ha. So muna ako chat na, sir, mali po dito. Kasi yung iba nagchat eh. Feeling ang galing. Sinabihan ko naman na mas may mali si sir, abangan mo lang matapos yung video. So, automatically, this is just negative 3. Okay, so, yun kasi iba. May gano'n kasi talaga. Nagchat lang sir. Tapos parang feeling niya, yun yung pinakamaganda niyang nagawa sa buhay. Ewan ko ba? Okay, so let's have number 2. So number 2, we have limit of sine 5x over sine 3x as x approaches 0. So automatically, this is 0 over 0. So no need ko nang ilagay yung ating L'Hopital's rule kasi i-apply na natin right away yung L'Hopital's rule. So this is the limit as x approaches 0. Then the derivative ng sine 5x. Oh my, nakalimutan ko yung derivative. Then derivative ng sine 3x. Okay, then this is just derivative ng sine 5x with respect sa x is just 5 cosine 5x all over 3 cosine 3x, and this is just limit as x approaches 0. Tama. So as x approaches 0, aware naman tayo na ang cosine 0 is 1. Okay, so this is just equal sa 5 times cosine 5 times 0 all over 3 cosine 3 times 0. Okay, so this is just 5 times 1 over 3 times 1, or this is just 5 over 3. So by L'Hopital's rule, the limit is 5 over 3. So check ko lang, ayun, tama, parehas naman yung sagot. Okay, so next is number 3. So naulit to, anong sagot dito? That is negative 1/2. So again, ganun ulit, alam natin siya ay infinity over infinity. Or this is just positive infinity over negative infinity. So we have limit. So gawin kong ibang kulay. Ay, doon na lang kasi doon yung kulay. So this is just the limit as x approaches positive infinity ng derivative with respect sa x ng 3x minus 1 all over derivative with respect sa x ng 7 minus 6x. Okay, so this is just simply limit as x approaches positive infinity ng 3 over negative 6. Tama, kasi derivative ng 3x minus 1 is 3, derivative ng 7 minus 6x is negative 6. Then, although since the limit of constant is just the constant itself, so this is just negative 1/2. Okay, so ibig sabihin, sir, from now on, pwede na akong gumamit ng L'Hopitals. Yes, as long as may limit akong diniscuss throughout sa ibang subject, kahit sa ibang subject pa may pinagdaanan tayong limit, pwede ka na gumamit ng L'Hopitals Rule. Kasi nga naituro ko na siya. Okay, so let's have number 4 rather. So pasensya na sa aking background song, hindi ko alam ano nangyayari sa kanila, hindi ko alam anong ginagawa nila sa buhay, pero again, alam ko naman kaya nyo pagpasensyahan nyo. Okay, so let's have this, no? So the limit of x squared over x squared plus 3x minus 10 all over x squared minus 4x plus 4 as x approaches from 2 from the left. Okay, so this is just basically saan siya equal, no? So hindi ko pa siya totally na solve, hindi pa natin alam kung paano natin siya apply. So apply muna natin ibang discussion. So kunyari in-apply ko literal yung 2. So kunyari lang in-apply ko sa taas yung 2. Pag in-apply ko yung sa taas yung 2, so kasi true from the left yan eh. So basically substitute mo lang yung 2. So that is 2 squared, that is 4 plus 6, that is 10. So 10 minus 10, that is 0. So 0 over 0 to. 0 over 0, tapos ito ay 0 over 0 din. Tama, no? 0 over 0 pa rin siya. Literal. So, kung gagawin natin, siyempre apply natin L'Hopitals Rule. This is just limit as x approaches 2 from the left ng derivative with respect sa x ng x squared plus 3x minus 10 all over derivative with respect sa x ng x squared minus 4x plus 4. So pasensya na sa mga lasig na kumakanta, mga buwisit dyan. So this is just the limit as x approaches 2 from the left ng 2x plus 3. So nakakaduling kasi dito. Then this is 2x minus 4. Sorry na, nakakaduling din talaga sa perspective ni sir. So next is siyempre apply natin yung limit nya, no? So paano i-apply yung limit nyan? So kung papansinin mo, pag in-apply mo yung limit nya, ano ba yung magiging result nya? Sa taas, i-apply natin yung 2, that is basically 7, no? Kasi 2 times 2 plus 3. Kasi kung 2 from the left siya, multiplier din naman niya kasi 2 times 2 from the left, that is obviously 4 lang din. Kumbaga hindi ganun kalaki epekto. Unlike dito sa kabila. So kung in-apply ko yung 2 from the left times 2, so ang mangyari kasi dyan, 2 times 2 that is 4 minus 4 kung sa substitute mo. Pero kung susundin mo yung body o yung nature ng 2 from the left na yan, so sa ilalim kasi susundin natin that is 2 times 2 from the left then minus 4. So ano idea ng 2 from the left na yan? Ang idea ng 2 from the left na yan is that is 1.9 something. No, 1.999 something na ganun, 1.999. So for example, 2 times 1.999 minus 4. So ayun yung idea ng 2 from the left na yan, ha? That's negative. Okay? So kanya dagdagan ko pa ulit ng 9. So kung napapansin mo, as dinadamihan ko yung 9, mas lalo siyang lumalaki yung denominator. So obviously umabot siya sa negative 0 or something na 0 from the left. So ano ba yan sa fraction? That is 2 something. So 0 from the left siya, literal. So habang lumalaki, this is just equal lang naman sa this is just 7. So again, sir, ba't sa taas hindi ka nag 2 from the left? Sa 2 from the left kasi sa taas, hindi siya nakaka-apektos mismo sa solution natin. Kumbaga, substitute ko lang siya, wala naman siya epekto. Kumbaga, substitute na lang rekta. Ngayon sa ilalim, dahil nasa denominator siya, kung ginawa kong 2 lang siya, literal siya na mag-0. So, mag-undefined. So, anong nangyari? Ginamit ko yung nature ni 2 from the left. So, yung 2 from the left na yung ginamit ko. So, obviously, 2 from the left, ang sagot dito is 0 from the left. Okay, so again, 0 from the left. So, pansinin nyo, that is 0 from the left. So, dagdagan ko pa ulit. So, yun na. So, again, 0 from the left yan. Hindi yan negative. Hindi yan 1 over 500, that is 0. Hindi ganun literal magiging gawin natin. Sir, infinity, hindi ganun. 0. Hindi ganun. Okay? So, again, that is 0 from the left. So, kung positive, 0 from the right. Ganun yung magiging sagot. So, basically, this is just 7 over 0 from the left. Ano yun? So, papasin mo, number over 0 from the left, divide mo yun. So, 0 from the left siya. That is, obviously, this is negative infinity. Okay, so again 7 divided by 0 from the left. So ano ba yung mga 0 from the left? Yun yung mga negative 0.00001. So for example, 7 divided by negative 0.01. For example, ayan lang. Ayan yung from the left ko. That's negative 700. Eh, what if damihan ko? Kasi nga from the left 0 from the left. 700. So dadagdagan ko pa 7 million. Okay, so ayun na. So again, bakit siya naging negative infinity? So ayun nga. So dinagdagan ko 7 over negative 0.001. So for example, bawasan natin sa ilalim, no? Bawasan natin ng 0. Sin mo yan. Okay, so dagdagan ko ng 0. So basta habang dinadagdagan ko ng 0 siya, or dinalaki ko ng 0.0000001, kasi from the left naman siya, automatically that is negative infinity. Palaki ng palaki. Okay, so kaya ganun yung explanation sa kanya. Okay, so next is number 5. No, so check natin si number 5. Paano ba ginagawa to si number 5? We have the limit of x cubed minus 3x plus 2 all over 1 minus x plus ln of x. So basically, what is pag sinubstitute yung 1, so that's 1 minus 3, that is negative 2. Kasi 3 times 1 is 3. So, 1 minus 3 times 1, that is negative 2 plus 2, that is 0. So, obviously, 0 sa taas. All over 1 minus 1, that is 0. And we all know that ln of 1 is just 0. So, 1 minus 1 is 0 plus 0, that is 0. So, basically, this is indeterminate form of type 0 over 0. So, basically, applicable pa rin si Lopital's Rule. So, by Lopital's Rule, apply natin sa Lopital's Rule. This is just equals sa limit as x approaches 1 ng derivative with respect sa x ng x cubed minus 3x plus 2 all over derivative with respect sa x ng 1 minus x plus ln of x. So, this is just equals sa limit as x approaches 1 ng sa taas is 3x squared minus 3. Sa ilalim is negative 1 plus 1 over x. Tama naman, no? So, negative 1, kasi derivative ng negative x is negative 1. Derivative ng ln of x with respect sa x is 1 over x times dx, or that is 1. So, meaning, wala naman mangyaring apekto to, no? So, basically, ano na lang gagawin natin dito? Indeterminate form pa rin ba to? Yes, indeterminate form pa rin, no? So, pansinin mo, guys, this is 3 times 1 square, that is 3. Minus 3, that is 0. So, this is just 0 over negative 1 plus 1 over 1. Kung sinabstitute correct, this is also 0. So, meaning, indeterminate form siya. So, dun papasok yung definition o yung conclusion ng ating Lopital's Rule, na kung saan, pag hindi pa nag-e-exist, automatically, gagawa pa tayo ng paraan. So, meaning, apply pa tayo ng panibagong Lopital's Rule. So, sakto yung aking papel dito, no? So, applying Lopital's Rule again, this is just the limit. As x approaches 1 ng, this is just 6x na lang. All over, ano ba magiging derivative ng negative 1? Derivative ng negative 1. So, in-apply ko na lang, hindi ko nalagay yung dx. So, sir, pwede na yun. Yes, pwede na yun siguro sa pangalawa para hindi masyadong mahaba solution. Sa una, lagay mo para makita ko naman in-apply. Pero doon sa pangalawang gamit, siguro, recta mo na kung magaling ka. Okay. Then, the derivative ng 1 over x is automatically negative 1 over x squared. So, alam natin yan. Ako nga alam ko So, dapat alam nyo yan kasi mas kayo yung nag-aaral sa akin. Okay, then this is negative 1 over x. So as x approaches 1, basically this is just 6 times 1 all over negative 1 over 1 square, or simply this is just negative 6. Okay, so therefore the answer is negative 6. So yung limit daw neto is just negative 6. Tama ba ako? Yes, tama si sir. Okay, buti na lang talaga may kode ko tayo. Okay, next is we have the limit ng cosine x over 1 over cotangent x. No, so yun nga, no, over 1 over cotangent x. As x approaches 0 from the left. Okay, so 0 from the left daw siya. So paano ba yung magiging ano nito? Ano ba yung cosecant x? So sir, paano ko ba malalaman kung ano yung value ng cosecant x? Ganito guys ha, para malaman nyo kung ano yung value ng 1 over cosecant x. Then from 0 from the left siya. 0 from the left siya. So ang gagawin mo, alam mo na ang cosecant x is 1 over sine. Okay, so ang gagawin mo lang is 1 over sine. Okay, so ganyan yung gagawin mo, no? So mag 1 over sine ka, tapos ang sabi 0 from the left. So pansin mo guys, that is 0 from the left. So for example, nag-ano ako ng 0.01, negative 0.01, negative 0.01. For example, nag-testing ako dyan, that's negative 578 agad. So again, balik tayo dito, dagdagan ko ng 0, lumalaki. So dagdagan ko ng 0, i-observe nyo yung value ha, lumalaki. So meaning, saan approaches yun? That is negative infinity. So sa taas daw, this is negative infinity. Okay, sa ilalim naman, that is cotangent. So cotangent, meron din tayong tangent. So that is 1 over tangent. Okay, so again, tangent, 1 over tangent naman yung cotangent. So paano natin i-evaluate? That's 1, then 1 over tangent, tapos 0. Okay, so ganyan natin i-evaluate. So ngayon, katulad din ng impact sa taas, 0 point something, negative 0.01. Check natin. So positive naman. So lakihan natin konti. So lakayan pa natin. So saan papunta? That is positive infinity. So ganun mag-test para malaman mo guys. So sana may natutunan ka sa akin sa ganung bagay, no? Ganun pala. Tapos pag ikaw na naman, ano nangyari? Okay, so next is, syempre by Lopital's Rule. So gawin natin yung golden rule ni sir, no? Apply natin yung limit. This is just the limit. As x approaches 1, ng derivative with respect sa x ng cosecant of x all over the derivative with respect sa x ng 1 minus cotangent of x. So ayun, walang hanggang derivative na naman, no? So check ko lang. So this is just equals a limit. Ayun, wala na yung 0 from the left. As x approaches 0 from the left, ang derivative ng cosecant x is negative cosecant x sa cotangent x. So this is negative cosecant x cotangent x. Then sa ilalim is derivative ng 1 is 0, derivative ng negative cotangent is negative cosecant squared x. Kung ako yung hindi nagkakamali. So this is negative cosecant squared x. So pag kinancel, syempre magka-cancel tayo dyan. So literal, this is just limit as x approaches 0 from the left ng negative cotangent x. So wala na pala yan, sorry, magiging positive na. So assuming na wala na kasi negative. Then cosecant x, kasi cancel isang cosecant. Okay, then ganun, balik ulit tayo. So try natin apply yung ating 0 from the left. So sa taas 1 over tangent. So 1 over tangent ng negative 0.001. Ayun, hindi ko naglagay. Okay, so check natin guys. So, ganun yata ulit, no? So, kung papansinin nyo, dagdagan ko ulit ng 0, lumalaki. Habang dinadagan ko, lumalaki siya through negative infinity. So, literal, dito daw sa taas, this is negative infinity. Okay, sa ilalim, so 1 over cosecant naman, 1 over sine rather, 1 over sine ng negative 0.001. Negative pa rin. So, obviously, this is negative over negative. Negative infinity over negative infinity. Okay. So, may nakalimutan si sir na gawin, no? So, ganito guys. Ang derivative ng cosecant x is negative cosecant x over cotangent x. Ang derivative ng cotangent x is negative cosecant x times negative. So, baka malito tayo, no? So, times negative kasi may negative pa dun sa labas. So, basically, this is negative. So, kung negative yon, so, ang mangyari doon, this is positive. Tama kasi negative infinity to eh. So, times positive, this is positive. Times negative, this is positive. All over, yung limit ng cosecant x as x approaches 0 from the left, this is negative infinity, guys. So, this is negative infinity. So, check nyo na lang din. Okay, now, applying another Lopital's rule in this value. So, we will have sa taas negative, no? So, this is just limit as x approaches 0 from the left nang magiging positive siya dito kasi derivative ng cotangent x is negative cosecant squared x times negative, that is positive. So, this is cosecant squared x. All over sa ilalim is negative cosecant x cotangent x. Okay, then ganun ulit, cancel isa. This is just limit as x approaches 0 from the left ng cosecant x over negative cotangent x. Okay, so check natin no, ano mangyayari dito. So pag check natin, that is basically similar ulit. Yung cosecant x is negative infinity, ito ay positive infinity. So, mangyayari, magbabaliktad lang. So, this is just negative infinity. Ito naman ay positive infinity. Tapos, nang gagawin, di-differentiate ulit natin sila. So, pag nag-L'Hopital's rule ulit, ang mangyayari, this is just limit as x approaches 0 from the left ng negative naman dito. So, kunyari na-simplify ko na, negative cotangent x, kasi kinancel ko na yung cosecant. Then, this is cosecant x naman. Tapos, ganun ulit, ang mangyayari na naman sa taas is just yung value niya is equal dito. Okay, so check ko lang ano bang ginawa. Okay. So, ayun nga, no. So, pag ginawa natin to, bato naman yung baliktad na form, ang lalabas naman dito is parang positive infinity over negative infinity. Tapos dito, derivative na naman natin, then blah 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 and blah blah blah. So, ano yung ating conclusion? So, paulit-ulit na positive infinity over negative infinity or baliktaran. So, paulit-ulit siya na indeterminate form. Ano ibig sabihin? Ang ibig sabihin lang nun, guys, is just hindi sa lahat ng oras applicable si L'Hopital's rule. Okay, so tama naman si Book. So, may nabasa rin naman talaga ang ganun eh. So, hindi sa lahat ng oras applicable si L'Hopital's rule, pero pag hindi daw talaga kaya si L'Hopital's rule. So, tulad nga nito, nagkaroon tayo sa example ng, ano siya, kumbaga, nag-involve siya ng ganito. So, paano yung gagawin natin? Paano natin i-solve? So, I think pwede siya i-solve hindi basta ng L'Hopital's rule eh. So, try natin i-simplify using trigo. No? So, I guess, try natin, ano lang to. Kumbaga, ito tayo dito, no? So, limit as x approaches 0 from the left ng 1 over sine siya sa taas all over 1 minus cosine x over sine x. Okay, then multiply the whole equation by sine x. This is just limit as x approaches 0 from the left ng 1 sa taas na lang, then this is just sine x minus cosine x. So I guess na-gets mo kung paano ko yung ginawa. Okay, then apply lang natin yung 0 from the left sa ilalim na yan, no? So, gawa tayo ng expression. So, gawa ka na lang sa calculus mo ng ganun. So, this is sine and minus cosine. Yan. So, ako, ganito kasi ginagawa ko. So, saka na ako magtatest ng 0 from the right. So, dapat parehas na value. Negative 0.001 as negative 0.001 din dito. Negative 0.001. So, tatlong 0 yung ginamit ko. That's negative 0.999. Okay? So, kung papalitan ko ng papalitan ng value yan, this is, kaya dagdag ako pa ng 0. So, pangalawang dagdag ko to ng 0. So, ginawa ko ng tatlo yung 0. That's negative 0.999. So, ano ibig sabihin? As x approaches 0 from the left, this is approaches sa negative 1. So, this is just equal sa negative 1. So, meaning ang limit daw niya is negative 1. But, the idea natin dito is just may mga L'Hopital's rule na paulit-ulit kang ilulup. So, technically, siguro lagi siya pasok doon sa mga trigonometric tulad nito. So, chain kasi sila eh. So, cotangent, cosecant, derivative ng derivative mo yan. Magsisimplify lang sila sa isa't isa. So, I think kasama din yan sa secant saka sa tangent. No, so second and tangent, ganun din yung mangyari. Paulit-ulit mo siyang derivative, paulit-ulit din siyang babalik dyan sa ganyang bagay. Okay, pero hindi ko rin sinasabi na basta ganun yung given, basta ganyang given, lagi ng loop. Hindi naman. Kasi nakadepende rin dito sa value. So, what if ang ginawa ko, fix na 0 to? Doon mag-iiba. Kung fix na 0 to, kanina pa to tapos eh. Tama. Okay, so, doon tayo proceed tayo sa last example bago natin tapusin yung video na to. So, hoping na nag-gets mo yung L'Hopital's Rule natin ha. So, let's have the last example bago tayo mag-proceed sa bagong indeterminate form of type. Indeterminate forms of type blah blah blah. So, evaluate the limit of x plus sin x over x as x approaches infinity. No? So, as x approaches infinity. So, paano ba ang una natin gagawin? Siyempre, obviously, kung ipapalit natin dito yung ating infinity, so this is infinity over infinity, automatic kasi sin of infinity, hindi natin alam kung ano lalabas dyan eh. So, that is, obviously, this is infinity over infinity, no? Or positive infinity over positive infinity. So, basically, apply natin si L'Hopital's Rule. Kunyari lang, in-apply ko na this is limit. As x approaches positive infinity, in-apply ko yung L'Hopital's, that is 1 plus cosine x. 1 plus cosine x over 1. So, pag in-apply ko yung infinity, ano mangyari? Pag in-apply ko yung ating infinity dyan, that is simply 1 plus cosine infinity. Eh, hindi natin alam yung 1 plus cosine infinity na yan. Okay. So again, ano ba yung cosine infinity? Ano ba yan? So, check natin guys. So, cosine, kunyari, 9. So, para matest yung cosine infinity, that is 9. Okay tayo dyan. So, next is, dagdagan natin ng 9. Okay. Dagdagan natin ng 9, positive. Pansinin nyo yung change ha. Dagdagan ko ng 9, positive. Dagdagan ko ng 9, positive. Dagdagan ko ng 9, positive, no? So, teka lang, napakakabot ako ng ulo dun. So, cosine 9, ayun, yun. So, cosine 9, guys. So, ayan na guys, tingnan nyo. So, kanina kasi may value pa eh. Yan, meron pa. So, dagdagan ko ng 9. Kasi nagtetend siya sa ano. Nag-iiba-iba yun, no? Nagmamat-error. Dagdagan ko ng 9, mat-error na. So, meaning, wala siyang value. So, cosine infinity, wala siyang value. So, same as dun sa sin infinity yata. Wala din siyang value. Or parang, so, in this part, does not exist siya. So, meaning, hindi siya nag-exist. Hindi siya infinity. Hindi siya 0, but do not exist. So, this is DNE. Sa part na to, DNE siya. So, ano naman ibig sabihin? Ito naman yung checkpoint o yung checkpoint natin sa L'Hopital's Rule natin. Or kumbaga parang ang dating is, may mga instances si L'Hopital's Rule dadalhin ka sa mas mahirap na part. So, tulad nito, nangyari dito, nag-DNE, nag-do not exist siya. So, yun naman din yung isa sa ayaw natin. So, although may mga sagot tayong do not exist, pero, may ibang way para masolve natin to. Okay? So, kung naalala mo si squeeze theorem, anong ginagawa natin sa squeeze theorem? Sinusolve lang sir, yung ganyan. Okay, so, start tayo sa squeeze theorem, no? So, kung naalala nyo, pwede tayo mag-squeeze theorem dito. Paano ba natin? So, consider natin yung x plus sin x by squeeze theorem. So, consider natin si x plus sin x. Sorry, ano muna tayo? Consider natin si sin x. Ito ay in between ng negative 1 saka ng 1. Mag-add tayo ng x. So, this is x minus 1 less than or equal sa x plus sin x. Then, less than or equal sa x plus 1. Magdi-divide tayo ng x. So, this is x minus 1 over x less than or equal sa x plus sin x all over x less than or equal sa x plus 1 over x. And obviously, anong gagawin natin? Kukunin natin yung limit ng dalawa para mahanap yung limit nito. So, obviously na yung limit ng x approaches infinity ng x minus 1 over x, which is equal sa limit as x approaches infinity ng x plus 1 over x. So, papasin niyo ang limit niyan ay both 1. Okay, so therefore the limit as x approaches infinity ng x plus sin x over x is just equal to 1. Ganun siya kasimple. Okay, so ayun nga. So, kaya kanina meron tayong L'Hopital's Rule na kung saan nag-infinite loop siya. So, kung continuously siya na hindi natatapos. So, nangyari, apply natin yung ibang method. So, next is, itong tulad nito, nag-apply tayo L'Hopital's Rule. Ang nangyari, dinala tayo sa do not exist o dun sa DNA, which is hindi natin gusto. Okay, so therefore, anong kailangan natin gawin? Kung tingin mo dead end ka sa L'Hopital's Rule, using L'Hopital's Rule, you can use still yung ating method na iba. At the same time, yung ating squeeze theorem. Okay? So, that's all and thank you for this time.